Hello and welcome to my video on how to calculate the average atomic mass of neon. We'll first talk a little bit about what the average atomic mass is, and then we'll do some calculations, particularly calculating the average atomic mass of neon. Now, we've seen atomic masses before. We've used them in a variety of other things. Looking at the periodic table, we saw them when we were doing periodic trends. Now, in this case, we have our square from the periodic table for neon. We know this 10 up here is the atomic number. This is the number of protons neon has. But we also have another number down here, 20.180. Now in this case, this is the average atomic mass for neon. This isn't the mass of one singular isotope. What it is the weighted average of all of the different isotopes for neon. So not every isotope is equally abundant. Sometimes for some elements, the isotope is much more abundant. So let's say 95% abundant, whereas the other ones are not so abundant or very small abundance. In that case, we want to give a little bit more weight to the ones that are more abundant. And so we take what's called a weighted average mass. Now, sometimes, of course, we have isotopes that are almost, let's say, 50-50 if there's two isotopes, but a lot of times they aren't. And we'll see this with neon because one of neon's isotopes is much more abundant than the other ones. So the average is calculated based on all of the isotopes and their abundance percentages. And this is how we calculate the average atomic mass. Here I have the equation for how we calculate this. We take the mass of our isotope times the percent abundance divided by 100. Now, taking the percent abundance and doing this divide by 100 step gives us that decimal. And in the case of this, we can keep going. So we can do mass of our isotope 1 times the percent of abundance 1 divided by 100, then our second isotope. And if we had more, we would just keep going and keep adding them on. So we could do as many isotopes as there are. Now let's look at particularly for neon. Now neon has three isotopes, neon 20, neon 21, and neon 22. And we can see here that neon 20 has 90.48% abundance. That means that most of neon, if you had a sample of neon, most of it would be the neon 20 isotope. 90% of neon is made up of that one isotope. 9% is neon 22, and a very, very tiny percent, 0.2710% is neon 21. So that one is a very small abundance, whereas we have a very large abundance from that neon 20. And this is why we do the weighted average. We want our average atomic mass to show what the average atom of neon would look like. And so most of the atoms of neon are neon 20. So let's start calculating this. What we're going to do is we're going to take the mass of our first isotope, so 19.992 AMU, and then we're going to multiply it by 90.48%, and we divide by 100. Now that is our first isotope. We're going to do our second one now. We're going to take 20.994 AMU, multiply it by 0.2710%, divide by 100. And then finally, we're going to take our last one, which is 21.991 times 9.253% divided by 100. Now those are our three isotopes for neon. Now we're going to take a second and we're going to calculate this. So when we do this on our calculator, we are going to take 19.992 times 90.48. We're then going to divide that by 100. Now in this case, we would get for this first one 18.0. Let's see, I'm going to keep my significant figures here. We'll need 4, so 0.9 AMU. Now we're going to add it. So let's do our next one. We have 20.994 times 0.2710 divided by 100. In this case, this one's going to be tiny because, again, this is a weighted average. So this one is only 0.2710% abundant. It's not very abundant. So it doesn't play as much into that weighted average. Now, again, keeping with our 4 significant figures, we will get 0.05690 AMU. And then our last one, 21.991, and I forgot the AMU here, but this is AMU, times 9.253 divided by 100, and we get 2.035. And those are our 4 significant figures. Okay, now remember, for addition and subtraction, we have some different rules for significant figures. We don't use significant figures for addition and subtraction. We use places after the decimal. So in this case, our 18.09 has 2 places after the decimal. Our 0.05690 has 5 places after the decimal. And then we have 2.035, which has 3 places after the decimal. So in this case, this takes precedence. Our answer will only have 2 places after the decimal. So what we're going to do is we're going to add up 18.09 plus 0.05690 plus 2.035. And what we'll get, remember, only 2 places after the decimal, we will get 20.18 AMU. Now this is our weighted average mass for neon. Now let's see how that matches up to the one on our periodic table. Here we have our periodic table, and neon is right up here, and we see neon is 20.180, and it matches. So we have gone through all the steps, we have done neon, but you could do this with any of the elements that are on the periodic table as long as you know their isotopes. So have fun calculating your average atomic masses, and good luck studying.